Hi boys, in this video we're going to look at the terms and definitions involved in the networks unit. Starting with the actual network itself. So a network is a set of connections between people or destinations or activities, and we're going to use plenty of different ones of these as we go through the unit, but basically they're going to look really similar to what you can see in that diagram there, where sometimes the letters there will represent towns or destinations, and sometimes the lines will represent roads or anything like that. So the vertices or one vertex are the points, and edges are the lines joining these points, and you can see them in that diagram there. So we call the orange dots vertices, and we call the lines that connect them edges. The degree of a vertex is the number of edges that come off it. Okay, so what I mean by this is, if you take A for example, you can see that there are 3 edges that come off it. So the degree of A is 3. If you take in B though, you see there's 1, 2, 3, 4, 5. So the degree of B is 5. Multiple edges exist when 2 vertices are connected by more than one edge. So you can see here that C and B are connected by 2 edges. So we say that there are multiple edges in this network. A loop connects a vertex to itself. So you can see that this line here, which I've drawn, actually connects D to D. It's important to note that a loop counts as one edge, it's one line, but it actually counts as 2 degrees because there's 2 lines coming off it. So if we were to count the edges for D, the degrees for D, there would actually be 1, 2, 3, 4, 5 degrees on the vertex D. A couple more things to note. A simple graph is a graph with no multiple edges or loops. You can see in here that this graph has multiple edges, so that's not a simple graph. An isolated vertex is not joined by any edges. So you can see here that J is not connected to anything, so we call that isolated. A degenerate graph has all vertices isolated. You won't see many of these, but it is important to note that. A connected graph is when each vertex can be reached from any other vertex. So you can see in this one here on the left that you can get from here all the way down to the other side very easily just by following the edges. However, to get from here to here, it's actually not possible. So we call that, well, we say that that is not a connected graph. And the next one is a complete graph is a simple graph, but it has every vertex connected to every other vertex. Alright, so going into an example, what we're going to do is going to ask a series of questions. The first one is find the number of edges involved in this network. So what we can do, remembering that a loop counts as one edge, there's 1, 2, 3, 4, 5, 6, 7. There are 7 edges. The number of vertices, well, there, remember, so 1, 2, 3, 4, 5. 5 vertices. Find the degree of each vertex. So in this case, the easiest thing to do is just to write down the number or the degree next to each of the letters. In A, it'd be 0. C, there's 1, 2, because remembering a loop counts as 2 degrees. 3, 4. Down here, E is 1, 2, 3, 4. D has 1, 2, 3. And B has 1, 2, 3. So the degree of each vertex would be 0, 3, 3, 4, and 4. The next question is involves a formula, and we're going to use this formula quite often, and it's to find the number of edges given the sum of the vertex degrees divided by 2. Now we can work out what the sum of the vertex degrees is by adding all of these together. Alright, so 4 plus 4 is 8, plus 3 is 11, plus 3 is 14. 14 divided by 2 equals 7. Is there 7 edges in this? Well, yes, there is, because we say that up here. So yes, we can confirm that the number of edges equals the sum of the vertex degrees divided by 2. The next example here is a complete graph. Now remember that a complete graph has every vertex connected to every vertex possible. Okay, so you can see that if we take this, for example, this is connected to that, which is both vertexes. This, if we take this one here, you can see that that line is connected to every other vertex in the graph. So that's what a complete graph is again. It's a different formula though. The number of edges equals n bracket n minus 1 bracket over 2, where n is the number of vertices. If we were to be asked the question, how many edges does a complete graph on 15 vertices have? All we have to do is go 15 minus 1 divided by 2. You would put that in your calculator, and the answer you would get is 105. If we were going to draw that, we would have to draw 105 edges across 15 vertices. It would just be way too difficult.